Okay, hello everybody. Welcome to my Mockist versus Classicists TDD session today. I'm glad to be here, and it was quite spontaneous. I think 1.5 weeks ago, Konrad made the proposal that I could share the talk, and yeah, great idea. Short introduction about myself. I'm David, I'm from Munich. Also for organizing the Softwerkskammer meetups over there. And yeah, in my day job I work for the codecentric company. And yeah, my focus area is test-driven development and software design. And yeah, so if you're interested in these topics, there's also my Twitter. What is up on the agenda today? First, we start with a talk. So I will introduce the Mockist and the classicist approach, and afterwards, talk a bit about how the different trade-offs between the two approaches and how they can fit together, or how they differentiate between them. And I will not only talk, I will also code a bit. So I think especially these approaches, TDD is very process, very concrete, very practical. So I think it's very important that you actually show something, because otherwise it's very theoretical. And yeah, I have an example with me. Yeah, and afterwards, of course, I hope we get a good discussion, good questions. So always feel free to ask. And yeah, hopefully we enjoy pizza and another beer afterwards. Good. Short disclaimer. I think it's very important. I don't actually like the title of my session, which is Classicist versus Mockist TDD, because it suggests that you should take one or the other. And I think the most important part, most important lesson you should take at home tonight is that these are two approaches, but you have to get a feeling when each approach is the best fit. And sometimes it's very, very good to even combine both approaches at different layers. But first, a question about you. How much do you know about classicists? Who knows this notion anyway? Classicist TDD. Who knows this Mockist TDD notion? And both? Yeah, obviously the same people. Okay. And who of you does actually use them in their daily work? Okay. Just to get a ballpark. Yeah, maybe we can just start a bit collecting some ideas. What do the Mockists? What do they do? What is their approach?
Interaction testing.
Interaction-based testing. Some other ideas?
Layers.
Structure outside approach somehow.
So you mean outside InDesign or something? Okay. So the Mockists are also called the London School, because they are the main proponents of this approach came from the London XP community in the early 2000s. They developed this approach, and Steve Freeman and Ned Price are the two guys which wrote this, I would say, Mockist Bible, the book Growing Object-Oriented Software Guided by Tests, from 2009, which is basically the Mockist Bible. But the ideas were developed already 2000 and a bit afterwards. David? So, okay. Sure. And yeah, J.D. Rainsberger is also today a very important proponent of the approach. Yeah, what problem do they actually try to solve? It's the problem that J.B. Rainsberger describes as integration tests are a scam. So these integration tests have a lot of bad properties, like mostly they are quite expensive. That's the most important part. And therefore the idea is to break the different parts up into small units that are independent testable. And the two major means, on the one hand, put interfaces between the objects that make these breaks easy, and on the other hand, mock them away. As you already said, this behavior verification, interaction-based testing, especially on, I call it always, non-leaf nodes in the object graph. So if you have several layers, so it's usually the node at the bottom objects. So the objects that have dependencies to other objects below them. And as I will show in a minute, the so-called outside-in design, which is a very nice side effect from the whole approach. Not exclusively for the Mockist school, but they like this double loop TDD a lot. So this double loop TDD is basically you start with a failing acceptance test from the outside of the system against the external system boundaries. And then you try to implement this functionality, this acceptance test tries to verify using several unit tests that try to drive the implementation of different parts that in the sum, if all of these single unit tests are passing, then also the acceptance test is passing. And this is usually combined with this outside-in. So this outside-in means I start with the border, often the UI or a REST service, or even the command line, so at the border of the system, and this acceptance test is written against this border. Usually it's driven by some user stories that you have to implement, and the acceptance criteria based that are in these stories. And these end-to-end tests fail at the beginning, and then you try to implement the first layer. You start with the first layer, and that is why it's called outside-in, because the outside is, in our case, the UI part here. So then you put an interface between the object under test and the collaborator object. In our case, there's a domain service below, and this service interface that is in between. Basically, this is the border between these two. And as this domain service is mocked, you can easily test it, unit test this UI component this way. And then you go down to the next layer when this test succeeds, and do the same again. And in our case, we have a database repository below. Then we write here an integration test, for example. And if this this leaf node in this speak is passing, then also the end-to-end test gets green. So the double loop is closed again. As you can already see, that we always put these interfaces in between. Of course, we start with a failing acceptance test, and usually you would write, we have an application that is a command line Twitter client, very simple. For the to not annoy you, I have not written it against really the main method or something, and standard out or something. Usually you would put the acceptance test at this layer. I won't do that at this point. I write it to the first layer, which is basically the Twitter client, and that is more kind of the GUI of the whole thing. Okay, so we have just a small problem. We have an account that is called Emergent Designs Twitter account, and we have 2 followers. The one is me and the David Völkl, and the other one is our host, a colleague of mine. And so the first test tries to do this. Yeah? It asks for the Twitter handle Emergent Designs if this string is rendered. Okay, so I start with designing the first part. So it's the Twitter client class and drive the external interface of the whole system. So what is important regarding design, that I actually at this point drive the external API or the external interface of the whole application. So at this point I actually do a bit of design, and that is not during the refactoring phase. Okay, so then everything is green, so I can execute it, and of course it fails because we have nothing implemented yet. And yeah, so yeah.
Could you scale a little bit?
Oh, good question. I have no idea. And anyone Eclipse? No.
Steuerung 3 und dann von.
Die Auflösung, okay. Try to scale the resolution down.
Oh no. Started. No, no. Other one was better.
Okay. Sorry. Yeah, I have no idea how this works. Anyone doesn't know the Eclipse settings with the formatting?
Mach mal eine grüne.
This one?
Nee, die andere.
This one?
Ist auch gleich.
Not perfect. Yeah, sorry for that. Okay, so this is only the acceptance test, so we won't do the actual implementation using this test that drives it. But as the start is quite similar, I will write a test for the actual client that looks quite similar. Okay, so I at first simply copy it, and now comes the big difference. Now we only want to test this Twitter client in isolation. So that means we have to think about the collaboration with the objects it depends on. So in our case, we have something like a Twitter interface below that is called. So this is kind of a back-end system we call, and I will just write it here. And which is quite typical, I mean, you can discuss that, is that we start with an interface and working against this interface. So usually, then we would think, how is this interaction with this collaborating object? And in our case, this is a rendered string, so this is kind of GUI logic, and we just need at first only the followers. So at this point, we try to design how this interaction with the collaborator should look like. And at this point, we also design this interface against. this looks like something like that. Fetch followers from the Twitter handle. So now we create it and then return the, in our case, we have not yet defined a good return value. So at this point we design the return value, which is, for the sake of simplicity, at this point a string of a list of strings, which contains the single followers. And yeah, to get to these, there should be something like arrays as list from our hosts and David Völkl. Okay, so now we have designed this interaction, and use at this point a mock. And the interesting thing at this point, so that we only created the interface that is before the collaborator. Okay, so then it's time to implement something. I mean, that has nothing changed, but has changed the test. And we get null. We still get null, so we jump in here. And as we can see, we need the Twitter client inside the object. So we drive it here and drive it into the object, because now to implement it, we need it. So now we do the actual call, but of course it's still the list of strings. So we have to render them down, and thanks to Java 8, that doesn't take as much, and I won't triangulate this at this point, and just do a simple thing. So now it compiles. Really? Okay. Okay. So in the integrating test, we have also the constructor has changed. So I just fill it with null because we don't need it at this point. We executed the test and doesn't work. Okay. So still the adds are missing. So we have to add them in between, and have to put them in front. Okay. Okay, what have we reached at this point? So we have developed the logic of this display method. And we have developed the interface to the next collaborator, to the backend. And the interesting thing is that at this point we didn't actually need a single implementation of this. It's fine that we develop it using a mock here. So now we started with the top layer, so now we go one layer down. So it's the second unit test we want to implement. And here it's quite important to look at the tests we already have here, because they make an assumption how this interface is called. So this assumption you usually should try to put into a so-called contract test. And this contract test says how this interface would work. So yeah, I just write this test. So it's, now we don't have only the interface, we also have we also need an implementation. So I call it Twitter REST API client. Test, because we start with the test. Okay, so now we have these, and the actual implementation has to fulfill this contract. So we have to actually do this call. Okay, so we need the Twitter before, Twitter REST API client, and okay, too much. I will fix it soon. Okay, so I'm now this actual call. Twitter handle is wrong. I have to put this, take this immersion designs as parameter. And then, okay, it's called client. No. It doesn't actually implement the interface. And yeah, now the return value we want to look into. So the followers, and assert that the followers do contain, okay, need them. And then we are here with these two values. Okay. Of course, this test still fails, sure, because we simply wrote the test. But it's important to keep these two in sync, because otherwise, if the contract is not met, the mocking doesn't provide the real value. Okay, so usually I would do it further down here, but at this point I will change gears, and we will switch from Mockist TDD to Classicist TDD. So, what, in your opinion, are the properties of Classicist TDD? Any ideas?
Chicken states.
Mm-hmm. So state-based testing. Any other ideas?
Inside-out design.
Yes, in some parts, but that is actually a quite interesting question. Controversial one, because the other one is possible, but as you said, from inside out is the more usual way to do it. So usually I would agree to you, but the other thing is possible, but more seldom species. Okay. I have to change the... Yeah. So the Classicist TDD is more kind of old school TDD, but more because the tradition is a bit older. The proponents are a bit older, like Kent Beck, for example, Uncle Bob, countless more. I think Ron Jeffries, countless. So, especially regarding, the classicists don't like mocking as much, so they try to avoid it as much and focus more on integrated testing of the whole stack. So one is the state verification, so asking an object for the internal state, for example, and yeah, some part of it is also called front door testing, which is more this idea that you only call this external public interface. But even the classicists do use mocking in some parts, especially when they communicate with external systems. And for third-party systems, they do it mostly. With a database, it's more between the lines, because sometimes they test it with the database, sometimes not. So yeah, it depends here. And as you already said, it's more the bottom-up design, and this works the other way around. So we start with these leaf nodes, so the nodes below that have no dependencies to other objects. So they are easy testable, of course. And they use it to drive some kind of small building blocks, and do some of them, and afterwards combine these building blocks together, integrate them together to a bigger whole, and then you have an integrated acceptance test that tests the whole thing together. So it's the other way around, basically. And yeah, I will also show you this how this looks in practice. I will do it here a bit like TDD as if you meant it, which is a certain style, where you start in the test methods. So you write the actual production code starting in the test methods, and that is quite useful, especially if you write those learning tests. And I will just use it to drive this this Twitter client API implementation, this REST client, because there I have to try some stuff out, and it's a good fit for it. So yeah, so it's the part below. Okay, I just changed the name here because that's awful. And for a short amount of time, I ignore this test because it still fails, so it doesn't provide any value for us at this point. So now it's green, but nothing is executed. So I just start the first part of it. Also, not to annoy you, I've prepared some code snippets that do this actual call, just to make it a bit faster. And yeah, so the first test just tries to call the REST service. There's a simple REST API. I've already closed the documentation, so not simple REST API. And so we just try to get some JSON back again from the service, and check if there's some these parts here as substrings. So I just take this and yeah, of course I have not yet an implementation, doesn't yet work. And yeah, I just take the implementation that I just copy and pasted from Stack Overflow. So this one. So this one provides the content, and this is the JSON. Okay, waits a bit. Okay, looks good. So now we have gotten the string back. I just make the test fail to get a part of the response, because the next building block we try to use is just the JSON and the parsing of the JSON. So that is the second part. So I do it, simply copy the response value and try to drive this partial functionality. Okay, so as you can see, I don't do the refactoring phase at this point in time. And yeah, just start with the assertion here. So what should be the result? The result should be a list of strings. So that are the followers. And we have some JSON string, which is basically input. I simply put it there. And yeah, the goal is that in my followers list, if I take them, that it contains these values from here. And yeah, we have to take care because I just broke it here. Okay. Okay, just to get it running and to make this test failing, of course it's still nice, so I simply fetch my prepared implementation, which does the actual parsing, and puts it into the followers variable, and yeah, now it looks good. Okay, so at this point, we, if you know this, the four rules of simple design, we only did make it work. So we were quite lazy regarding the refactoring part. So it's time to design a bit. We have completely no design at this point here. It's plain implementation, the flat implementation. So now we try to extract some stuff and pull the design up through refactoring. So this is application of some parts of the four rules of simple design, mainly the make it clear, expressive, and consistent. So this is mostly the extract method refactoring, providing intention, revealing names. And so this would be something like, what do? We have a JSON and fetch, parse the followers. So it's parse followers from JSON. So arrange act assert style, and here, what do we do here? We fetch the follower JSON. And so, okay, at this point, we only developed in the test, so this point it's time to move them into the actual implementation class. So I start to make the implementation class a field. So this is more removing duplication, and actually make it a before method, so it's set up correctly for us. And now it's time to move the actual implementation methods over there. So I'll just take these two, move them over there. Oh, that's bad. I don't know why this happens, but I had a problem before and I have to restart the IDE now. I don't know what the exact problem is. I usually don't have this, but yeah, we will try. And and as my SSD is some years old and almost full, it's quite slow. Okay. So try it again. I try to move this method to the other class, and also this one. Okay, so now we have the whole production code over there, and yeah, now I think it's time to we still have the fetch followers. Okay, no, it's we actually should improve the method names. I simply take these and this one. And yeah, so now it's time to comment in the back the ignore test, which is kind of the test that does the integrating stuff, and of course it still doesn't not work because we have not yet implemented it. And so now we are at this point where we take this, we have prepared these small parts that we now can combine together. So we have done the building blocks, now is the time to combine them together. And yeah, I simply take fetch follower JSON and surround it with the path. Now, okay, so there's still an exception, and okay, so I simply do a dummy, get rid of those checked exceptions. Okay, so now it could work. And does actually work. Okay, so now this was kind of the more integrating tests from these both parts. And now, as I have combined it before with this outer real acceptance test, this one should also work at this point. So I take the feature test, which is the acceptance test. Now this one should work. Does not work yet because we have not yet the real Twitter client, only null here. So it's Twitter REST API client or something. And should work now. Okay. So usually I would do a lot of extract method and intention revealing name stuff at this point, like I don't know, something like that. Or I mean, there's a lot of stuff to do, so that would be more the kind of yeah, bottom-up immersion design stuff, but yeah, to not annoy any longer, I will shorten that and yeah, switch to the actual presentation again. So yeah, now we want to have a look at the properties and the trade-offs we can do at this point. So as we already have seen a bit, this outside-in versus inside-out design is, yeah, as we heard, outside-in is almost mandatory for this Mockist style London School TDD, but sometimes Classicists can be an option, but usually inside-out is the default. What is quite important here is that we, through this outside-in design, we reach a very good fitting design for our that fits very good to our problem, because we drove it from the outside into the system, and it has to do the thing we really require, which should be the acceptance test, to perfectly fit into this. Otherwise, so this you ain't gonna need it or YACNI, it can happen very easily that we develop, if we work from bottom up, that we develop stuff that is not really useful. So you build some small parts, but some of them you actually don't need any. Because you thought you would need them, but you don't need them, actually. What is, in my opinion, very interesting, if you think about when to use which approach at this point, is to think about how clear is the inter-object design at this point for you. Because very often you have an application where you have certain layers that are almost always taken. Or you almost always use the model view controller, for example, and then a service layer, and then a repository below. So it doesn't. You can reach these designs through this emergent design from bottom-up TDD. Yes, of course, but this is a lot of work, and usually it's a very good bet to use at this point this outside-in design, where you have to know how you design this object interactions at the point when you write the test. So it's not afterwards doing refactoring and extracting and stuff. It's at the point where you write the test. So you have to know it in advance. But if it's quite clear and it doesn't change very easily, then it's a very good fit for this outside-in approach. On the other hand, if you have a thing, like in our case, this API, which kind of grows from the bottom, and you don't know how this, it's a new domain, for example, you don't know how you will layer it and do stuff there, do the design there, then it's probably more interesting to use the classicist and to work with emergent design at this point to reach a certain design. So I think that is a very critical criterion. Also have a look at other properties. One common objection against the Mockist TDD is that mocking actually freezes the code. Refactoring gets very hard, and also people always say it binds it to the implementation. And there you have to think about, on the one hand, if you do the Mockist thing and the design is already quite mature, then you won't have a lot of these refactoring problems. So again, it fits quite well together if the design is already quite fixed. If it is quite volatile or you can't predict it, it's probably not a good idea. So this can be another. It's basically the same, but regarding the refactoring. One thing that is quite interesting to look at is I/O in the system. So I/O is always input output, and just start with what I/O does the front door or the classicist, what do they use? So they usually in the functional style take simply an input and return an output. That's basically data transformation or something, calculation. Or they do something like, this is more kind of mutable objects. They do change the state and afterwards take this state-based testing, fetch the state, fetch a certain state that is dependent on this input afterwards. So the input and the output is visible from the front door means the public interface. On the other hand, there's the back door when you look at the Mockist. They also have the public interface, but additionally they have I/O below, and that is called why they call it backdoor. So start with the input. The input is the queries that you put to the layer below, so something like find all customers or stuff. And usually when you combine it with mocking, then you only use this when clause or something. So this is usually in the test, the test notions are usually called stubbing at this point. You feed input data into the system, but from below. And the other part is the output, the backdoor output, and they usually are called test spies. This is a very critical term, so sometimes people only say mocks. Yeah. Fair enough, because spy is quite used differently. But the main idea is that method below is called that has an actual side effect.
Would the classicist test a layer that is upper in this stack of layers? So if you test a lead layer, where you don't have any integration going on, it's easy. But when you integrate parts and don't want to execute all the parts that are below, how would they do it? Will they call the database every time?
Yeah, it depends. Sometimes they even use mocks at the borders, but very often, especially with the database, they simply put it.
Okay, but they would run the whole subsystem in the test of a higher level then?
Often, yes. But especially with the database, it's kind of both.
Yeah, okay, the database is extremely example.
But if you call a mail gateway or something that has a side effect, there even then the classicist needs the mock because he has no other possibility to take this.
A simple example would be a service function which uses a lot of helper methods, for example, or some other methods that are in the objects around. So if they want to test this public service method, they also test everything else in between.
Yeah, yeah. Okay. So that's their thinking. But yeah. Nevertheless, mocking has a lot of nice benefits, like the outside-in design, but there's also drawbacks. Probably most people of you don't like mocking for a certain reason, because mocking is a bit awkward to write and especially to read, because it's a bit harder. It's a bit more verbose. If you call this here query, then return, it's a bit more like just giving a parameter as input value. Same with verify, it's a bit more, you have to think a bit more. Other things, there are certain frameworks like JMock, for example, that put the expectation part, which is verify and Mockito, which is a bit different, put them up, so they do arrange, verify, so it's the assert part, and then the execute. So if you are used to this arrange, act, assert style of testing, or give it when then, or whatever, then it's a bit disturbing, because the order is changed. Huh? So you get used to it after a while, but yeah, it's not very intuitive. And of course, mocking non-primitive values is doable, but it's also a bit harder. Yeah? In Mockito, you need this argument capture. It's simply awkward. Yeah, so this is more kind of additional slide, I would say. So how do actually the classicists do the isolation? Do they the isolation? So very often they do it not. So if they only do use the front door, and I mean the leaves are not the problem, but the non-leaf nodes, they often use integrated tests for that. So sometimes that can be okay, especially if the controller does only data flow work. Does only one call and has no logic. Then probably it's no big problem to have the integrated tests. If there is a lot of logic, it gets more tricky and it should be avoided, because then you run into these problems with this integrated tests, which are very hard if you have a lot of combinations, because you have to combine the possibilities from the lower layer with the possibilities from the upper layer, and then you get a lot of test cases, and that can get quite awkward. Quite annoying, because it's a lot of work to do. So there are nevertheless some approaches there that try to minimize the conditional logic and try to push the logic down the call stack. I won't go into detail here because they're quite advanced topics. But if you are interested in this, I have written down some stuff. Yeah, it's often comes from more the functional communities, or how they do such things. From Gary Bernhardt, there's an excellent talk I reference here, Boundaries, where he talks about this functional core and imperative shell, where he tries to separate the I/O from the actual logic, and this helps very much. This data flow doesn't have a lot of combinatorial possibilities, so it's quite easy to test, and it's not so problematic to have integrated tests at this point. So let's sum up a bit. I try to put a bit together. This is probably not complete or comprehensive, but the main criteria that are important for this design trade-off. So it's maybe the most important is how much uncertainty is in your design. So usually, very often in a larger application, you have very clear layers and responsibility separation. So there usually it's quite good fit for using Mockist TDD. And another thing is how much complexity is up in the upper parts of the call stack, in the non-leaf nodes. If you have a lot of complexity there, then probably the integrated tests won't work very well. If there is not much, then probably you can simply take a simple one integration test, and you have only one path, for example, then you don't need a unit test just to see if the value is passed through. What is also quite interesting that it's a bit correlated to architecture at this point. So have a look at the I/O of your system. Where are the I/O points? So where do you question an external system, and where do you throw a side effect at another system? It's quite natural if you have a lot of these that you have to mock these, of course. Yeah. And the other thing is, I would say message passing or event-driven architectures, where you have these, where you have a lot of sending messages to other systems, or just simple messaging, middleware or stuff. There's also this output stuff that fits very well together with the Mockist style. Yeah, I think we can come to the conclusion. I will finish with the stuff I started with. So don't think either or, more think choose the right tool, choose both of them, but each of them for the right job. Thank you very much.